column is a vertical structural element that primarily carries compressive loads. It transfers the weight of the structure above it, such as floors, ceilings, or roofs, down to the foundation. Columns are fundamental components in both traditional and modern construction, providing support, stability, and strength to buildings and other structures. Columns can be made from various materials, including concrete, steel, wood, stone. They vary in shape, such as circular, square, or rectangular, and size, depending on the structural and architectural needs. Uses of a column. Load-bearing support. The main use of a column is to support vertical loads from the structure above and transmit them to the foundation. They help prevent structural collapse by distributing weight evenly. Architectural design. Columns are often used as aesthetic features, especially in classical architecture, like Greek and Roman styles. Decorative columns can enhance the appearance of buildings, both inside and outside. Structural stability. Columns help in maintaining the overall stability of a building, especially in multi-story structures. They resist bending, buckling, and other structural forces. Partitioning and space planning. In large buildings, columns can help divide space efficiently. Their placement can influence the layout and functionality of interior spaces. Support for arches and beams. In bridges, auditoriums, and halls, columns support arches, beams, or slabs, forming a complete structural system. Conclusion. Columns are essential elements in construction, serving both functional and decorative roles. Their ability to support heavy loads, maintain stability, and enhance design makes them indispensable in architecture and civil engineering. Columns are one of the most fundamental and visually impactful elements in architectural design. They serve both structural and aesthetic purposes, acting as vertical supports that transfer loads from the structure above to the foundation below, while also enhancing the visual rhythm, proportion, and grandeur of a space. 1. Historical context and evolution. The architectural design of columns has evolved over centuries, influenced by cultural, technological, and stylistic changes. Ancient Egypt and Mesopotamia, early columns were massive and carved with symbolic decorations, often imitating bundled reeds or papyrus plants. Classical orders, Greek and Roman. This era formalized column design into the Doric, Ionic, and Corinthian orders, each with defined proportions, decorations, and entablatures. Byzantine and Gothic, columns became more slender and ornate, often featuring elaborate capitals and clustered shafts. Renaissance and Baroque. Architects revisited classical principles with renewed emphasis on harmony, symmetry, and artistic detailing. Modern and postmodern, columns transitioned into abstract forms, often minimalistic or expressive, using new materials like steel and reinforced concrete. 2. Components of a classical column. Traditionally, a column is composed of three main parts. Base, the bottom portion which rests on the ground or a plinth. Not all classical orders include a base, e.g., Doric. Shaft, the vertical, often cylindrical part of the column. It may be fluted, grooved, or smooth. Capital, the topmost element, acting as a transition between the shaft and the structure above. Each classical order has a distinct capital design. 3. Structural function. From a structural engineering perspective, columns are critical load-bearing elements. Key considerations include axial load capacity. The column must support vertical loads without buckling. Material strength. Different materials, stone, wood, steel, concrete, offer different load-bearing capacities. Slenderness ratio. This determines stability and resistance to buckling. Connection to beams/slabs. Proper anchoring at the top and base ensures stability and effective load transfer. 4. Aesthetic and symbolic roles. Columns are not just utilitarian, they carry strong aesthetic and cultural meanings. Proportion and order. Columns help create balance, rhythm, and hierarchy in design. Symbolism. In many cultures, columns represent strength, support, and continuity. Visual focus. They can define entrances, frame views, and accentuate facades. 5. Contemporary design approaches. Modern architecture has expanded the possibilities for column design. Material innovation. Use of composite materials, glass columns, and high-performance concrete. Form exploration. From twisted and branching columns to tilted or irregular shapes, contemporary designers often challenge traditional verticality. Integration with systems. Columns may incorporate lighting, HVAC ducts, or even water features in advanced designs. 6. Column design in interior spaces. Inside buildings, columns may be exposed as design features or hidden within walls. When exposed, they can act as sculptural elements, create divisions or rhythm in open-plan layouts, be combined with other design elements like arches or shelves. Conclusion. Columns are a timeless element in architecture, embodying both the principles of engineering and the beauty of artistic expression. Whether rooted in ancient traditions or reimagined through modern innovation, the architectural design of columns continues to shape the character and identity of spaces around the world. Historical context and evolution of columns. Columns are a fundamental element of architecture, serving both structural and aesthetic purposes throughout history. Their evolution reflects broader cultural, technological, and artistic shifts in human civilization. 1. Ancient origins. Egypt, circa 2600 BCE. The earliest columns appeared in ancient Egyptian architecture, where they were primarily used in temples and tombs. These columns were often carved from stone and decorated with elaborate capitals resembling lotus blossoms, papyrus, or palm leaves, plants considered sacred in Egyptian culture. Mesopotamia. In Mesopotamia, columns were less structurally significant but often appeared as decorative features made from brick or wood, supporting roofed spaces within palaces and temples. 2. Classical antiquity. Greece, c. 600 to 300 BCE. The ancient Greeks formalized column architecture with three primary orders. Doric, the simplest and sturdiest style, with a fluted shaft and a plain capital. Ionic, recognizable by its scroll-like volutes and more slender proportions. Corinthian, the most ornate, featuring acanthus leaves and a highly decorative capital. Columns in Greek architecture were integral to temples, like the Parthenon, and emphasized harmony, proportion, and rhythm. Rome, c. 300 BCE, 400 CE. The Romans adopted and adapted Greek column styles, adding their own, e.g., the composite order, a blend of Ionic and Corinthian. They expanded the use of columns to a wide range of structures: temples, basilicas, baths, and monumental arches, often more for grandeur than structural necessity. With concrete construction, columns also became more decorative than load-bearing. 3. Medieval period, c. 500 to 1400 CE. In early Christian and Byzantine architecture, columns were reused from Roman buildings or adapted with Christian iconography. During the Romanesque and Gothic periods, columns evolved into compound piers and clustered shafts that supported vaulted ceilings and arches. They became more slender and were integrated into the overall verticality of cathedrals. 4. Renaissance and Baroque, circa 1400 to 1700 CE. With the Renaissance revival of classical antiquity, architects like Brunelleschi and Palladio reintroduced Greek and Roman column orders, emphasizing symmetry and proportion. Columns became symbolic of intellectual and aesthetic ideals, often used in civic buildings, churches, and palaces. During the Baroque period, columns gained a more dynamic and theatrical character. Twisted, Solomonic columns and richly ornamented capitals were used to create dramatic interiors and facades. 5. Neoclassicism and modernity, 18th to 19th century. The 18th century Enlightenment renewed interest in Greco-Roman forms, leading to neoclassicism. Columns were widely used in government buildings, banks, and museums as symbols of order, democracy, and permanence. In the U.S., for example, Jeffersonian architecture incorporated classical columns to reflect ideals of the new republic. 6. 20th century to present. With the advent of modern engineering and materials like steel and reinforced concrete, columns were no longer necessary as primary supports. However, they retained symbolic and aesthetic functions. Modernism emphasized clean lines and minimalism, reducing classical columns to simple cylindrical or rectangular supports, e.g., Le Corbusier's pilotis. Postmodernism reintroduced columns in playful, ironic, or exaggerated ways, often referencing classical forms. Contemporary architecture uses columns in innovative structural and sculptural ways, integrating advanced materials and engineering to create new visual and spatial effects. Conclusion. The column has evolved from a vital structural necessity in ancient stone temples to a versatile architectural element that can signify tradition, authority, elegance, or innovation. Its enduring presence across civilizations and styles underscores its importance in architectural history and design.